Hello everyone, welcome to this introduction to programming and web development learning part. Here is a little about myself. My name is Jeremiah Ezekiel, a student of Brigham Young University, majoring in software development. During the course of my studies, I've gained practical experience working for a couple of companies and clients as a junior developer. In addition, I have also worked on a couple of personal projects that incorporate different technologies using programming language such as JavaScript, Node.js runtime, C Sharp, and the .NET ecosystem, Python, and its libraries to solve real-world problems. My goal is to give back to the community and as much as possible to help others who want to toil this path become better at it. In this video, I'll be sharing both theoretical and practical experience to ensure that you, the viewer, get better with your learning and apply what you are learning to solve real world problems. So here is the table of contents that we'll be talking about in this particular video. And we'll be talking firstly about the overview of this learning part. We'll talk about what this part entails, what you're likely to see, and yeah, practically the fundamentals of the mindset that you need to have in you as you take this learning part. Secondly, we'll talk about programming versus coding. Now, these two terminologies are used interchangeably by some upcoming devs or some persons that don't really have idea about what they are. So in this course, I'm going to ensure that I explain this better. Then we'll go to the tools and materials needed to be able to do our job and to learn and then to solve real world problems. Then we'll go to the common myths about software engineering. There are some things that people say about software. Some say that it's only genius, and then it's only genius that do software engineering. Some say it's not meant for everyone, but then when we get to that session, we'll talk more about it. Also, we'll also talk about the branches of technology and software development. The ecosystem of technology is so broad that one cannot do everything. So there's a need to pick up a particular skill in the ecosystem and get better at it. Also, we'll talk about the career mindset and the growth path. Yeah, that's what we'll also talk about. And lastly, we're going to talk about how to succeed in this class. So I encourage you to watch this video to the end so that as you begin your journey, you have a wonderful experience learning for yourself. So now we'll talk about the overview of this class, and then so let's go over to what is software engineering. Now, a lot of person have this understanding or misunderstanding about what software engineering is. So, uh, software engineering is a broad discipline. It's very broad. When you say you are a software engineer, you are talking about having the skill to be able to create and develop software across um, it could be across different technology stacks. So software engineering is simply means designing. You are responsible for designing, or you can contributes to designing, building, testing, and maintaining software systems. So we know that a software is uh, part of the computer that you can't see or touch but carries out a particular function. Let's take, for example, we have the social media apps today. What the apps do is to help you create content from your home and publish it to the world where anyone can view it. We also have specialized softwares. Let's say the Excel is a software that carries out calculation for data analysis and other functions. We'll also have we have different softwares. Even the Google Chrome is a software that helps you to view web app application. So a software engineer is simply someone who has the idea of designing, who can design and build. He also test and maintain software systems. That's what software is. And then it includes collaboration also. Most software engineers don't work alone. They usually do it with their fellow engineers. They do it with the clients. They do it with the users so that they can continuously improve the software. Okay, so you use the web every day, social media, shopping, and learning. Today, you are stepping behind the curtain to learn how it's built. So, web development is a process of designing. Yes, you cannot build a website without designing it. There's a need for you to design the look of it and also building the actual building and also maintaining it. Yes, for both websites and web applications. So websites and web applications uh, are same thing in a way. It is called an application because most times the mobile application that is being used, the website can do most of it in your web browser. Now, the application in the mobile device, you need to download it and install it before using it. But that's of the website, you don't need to download it. You just have to use it the through the Google Chrome, which is a browser. Yeah, you need to use it through a browser, so there's no need to download it. But as time has evolved, our website has also evolved with time. Website has also evolved to be more like an application that reside in the browser. So therefore, they are now called web application, and because of the complexity of it, it's now called web application. So it's not just about writing code. It's not just about writing code. It's about creating experiences that people interact with every day, from a simple personal blog to complex platforms like online stores and social media platforms. And then we also have networks and cloud-based applications. And we'll also talk more on that. We'll talk more on that as we move on with our class. So this is a typical example of what a website look like. And this part of it is the code, and this other side is the final product of the website. So as a web developer, you'll be writing code and writing programs to to make sure that you have a final product that people can use. So a website, we'll not talk about what makes up a website for now. We'll not talk about what makes a website for now, but we just have to understand that web development is part of the software engineering. So is kind of a part in software engineering. So now let's talk about the difference between programming and coding. Now, so programming is about designing solutions, breaking problems into steps, and deciding how a computer should behave. Now, programming involves logic, planning, algorithm, and thinking about efficiency. So, programming is the logic, thinking about how you're going to implement a particular logic. Imagine being asked to count people in the room. You might say, okay, let me go inside the room and count everybody one by one. You can also say, okay, call somebody inside the room and ask the person if the person is the only person in the room. If the person said is not the only one, let him ask the person that is close to him, and then add him to add the person to himself. So maybe everybody counting themselves, adding one to each person. So that is algorithm. So programming involves thinking about the efficient way to solve a particular problem. Now, programming is the big picture. It's the big picture in software engineering. So it's not like every time you are on your laptop. No, programming involves thinking, problem solving. It involves planning, and it's the big picture. While coding is the implementation. So you have designed, you have planned, and you have thought about it, and now you want to implement it with a specific language, with a specific programming language like Python, JavaScript, that a computer can execute. So coding is one part of programming, but programming also includes problem solving, testing, debugging, and design. All right, let's talk about the tools and the materials that you'll be needing as a web software engineer in general. So first of all, the hardware that you need your laptop with a stable internet. Now, there have been cases where people claim to have been developing websites using their mobile phones, but mobile phone it's very small, the screen size is small, and then it's not user friendly. So preferably a laptop is the best to for developing websites and systems. And then a laptop should be able to have a 4 gig RAM, 8 gig preferable. Now the reason why this is because you'll be running applications as you develop. So if you don't have a very good RAM, your laptop might slow down and then it will not give you a very good experience while developing. So you need a laptop with at least 4 gig RAM and 8 gig preferable, with a stable internet connection. And the software that we need, you need a VS Code. VS Code is a friendly, extensible code editor. Uh, there are other code editors, or should I say IDE, IDE stands for Integrated Development Environment. IDE is a software application that combines essential uh, uh, developer tools like code editor, debugging, compiler, and build automation into a single interface. And then, so while some also use the term to refer to old storage interfaces like integrated drive electronics, this IDE stands for Integrated Development Environment, and the popular one is the Visual Studio Code. Now, Visual Studio Code is very ideal. I've been using it throughout my learning and my experience so far. There are other ones like Sublime, and we also have the PyCharm and Eclipse, but Visual Studio Code it's mostly popular in the community. Yeah, so I'll recommend using Visual Studio Code, and that's what we'll be using in this class. And then we also have Chrome and Firefox. Now, Chrome or Firefox simply browsers. That's what you use in testing your website, the website as you create and develop the website. So use Chrome and Firefox for debugging and then testing the product and the website that you've created. Also, we need Git and GitHub. Now, Git is a version controlling system. It's a code version controlling system. And what does that mean? Before version controlling system was built, when a developer implement a particular code in its project, and if he wants to show another developer or engineer, he or she will usually carry his laptop to the person or put the code in a flash drive and then take it to the person. The person run the code in a system. Sometimes if the system is not compatible, they have to be manual set up before the code can run, which is a very tedious process. But when Git came in, you there's no need carrying the Git and GitHub came in, sorry. There's no need taking the software, the code to somewhere. You can just send it over GitHub, and then the person pull it from GitHub, make changes, send it back to GitHub. You pull it, and then if the current change is not compatible and you want to go back to the previous one, what you simply do is to is go back to the previous one without needing to make manual changes a lot. So Git and GitHub is a must-have skill if you want to be better software engineer. You learn it and use it every day, and it's also a collaborative tool. So yeah, some developers can work on other aspects of the software while you work on other aspects of the software. At the end of the day, there's a merge of all the works that have been done, all the code that have been implemented and packaged and then run as one application. So it's very essential that as a beginner and a developer, you need to start learning how to use Git and GitHub in every of your projects. So the next we'll go to the learning resources. We have the free code camp. The free code camp is free, as I said. So if you go there, there is an interactive learning environment where you can learn whatsoever thing. You can There are different parts of tech in there that you can actually learn, and then good documentations to help you become better at what you do. If you run into any problem, there's also a community that you can ask questions, and then you will be replied, and then your problem can be solved. Then MDN Web Docs is a documentation site by those in Firefox, and then there's a huge chunk of documentation for JavaScript, HTML, and CSS in the MDN Web Docs. So if you ever run into any challenge or problem, just look up their documentation for solution. Also, well, W3 Schools is also there for learning and then documentation. So you can simply go there whenever you run into an issue. So first, I would recommend reading MDN Docs if you run into any challenge as a beginner, and then FreeCodeCamp community before W3 schools. So let's talk about some common myths about software engineering. Now, there have been uh, ideas or mindset about software engineering that we'll want to um, debunk and affirm in this particular session. So the first one is coding is equal to programming. Like we have rightly said before, coding is not equal to programming. Coding is just one piece of programming. Programming requires problem solving, critical design, critical thinking, designing, and a whole lot of that, testing. So, um, coding is the implementation of your ideas. It is not the it's not programming in general. So coding is not programming. So when you said I am coding, you actually mean you are implementing. Then when you say I am programming, it means it can mean a whole lot of things, from actually thinking about how you are going to solve a problem that you are facing. Then secondly, coding is only about memorizing syntax. And when I first started, I was like, okay, when I'm given a problem, I feel okay, there's only one way to solve the problem, and then I use JavaScript to try to solve the problem. And when someone else solve it in another language, I never thought about that until I do see similar solutions that other people use other language to solve. So coding is not only about memorizing the syntax. Syntax matters, but the real skill is thinking logically and structuring solutions. Tools like Google documentation and AI assistant can help with syntax, but coding is not only about memorizing how to write the the program using a particular language. Now, thirdly, you must be a genius to code. Lie. In fact, personally, I have struggled with learning how to code, like learning generally. So, code programming is a same thing as a skill. Is a skill that needs to be nurtured, that needs to be practiced to get better at. So you don't have to be a genius before you can learn how to code. Some person when they hear programming, oh, this thing is very difficult, and then no, it's not difficult. As long as you put your mind to it and you said you want to do it, you can. You might not actually use it in the meantime, but then it's like any other skill. It's like any other skill that you get good at as you continue to do it. Anyone can learn how coding with practice. It's more about persistence than raw intelligence. And some people will say it's only men that succeed in tech. That narrative have shifted a lot. We have a lot of women in the tech world that actually write actual programs and then build AI programs and the rest of them. So it's not just for men, it's for everyone. If you have the desire, you will learn how to code. And fourthly, programming is typing fast. We watch those movies that you see a hacker or someone go into a system and then start typing fast, and then quickly takes the drive off and then run away. And that's the mindset a lot of people have about programming. It's not true. It's not true. It's not about speed, it's about clarity, it's about accuracy, and it's about solving problems. So you might not even write a single line of code for a long time, uh, but you need to think about, because you need to think about what you are writing. Yet, so your code might just be about uh, 30 lines of code, 30 lines, but then it will take you more than 4 hours before you can actually get a better clarity on how to implement something. So another one is, once you learn one language, you're done. That's not true. There are so many programming language, yes, but it is not language specific. It is the concepts. What matters is learning the concepts. The concept of variables, loops, conditionals, data structures, and the rest of them that apply across all languages. You use loops in Python, in JavaScript, in C Sharp. You use conditional statements. Even in Excel, you use conditional statements. You use loops. You need to understand how your data is structured. So these are fundamental concepts when it comes to telling a computer what to do. So it's very important that you understand this fundamental concept before moving on. So if you are asked to program in any language, you can actually do it very well without needing a particular language, because you understand the fundamental concept of programming. So that's it for some of the minds and about software engineering. You don't Coding is not programming. Uh, Coding is not only about memorizing syntax. You must not be a genius. Typing fast doesn't mean you can program. Yes, and then understanding the basic concepts of programming is more essential than learning one particular language. So as we all know, the tech world is very broad, and then even in software engineering, there are a lot of things that you can do as a software engineer. There are lots of places you can apply your skills. So I'm going to show a table of some of the skills that are currently in demand, and then we'll talk a little bit more about them. So we have the web development, which is what we will be discussing in this class. And what it focuses on is websites and web apps. So they are applications that are mostly viewed from the web browser. An example of a career path that you can take, you can decide to be a front-end developer that specializes in HTML, CSS, JavaScript, and front-end frameworks like React, Vue.js. And then you can also decide to be a back-end developer. That what it does is to what back-end developer do is programming server, now carrying out building programs that have to do with the business logic. They are mostly called server-side applications. Or you can decide to be a full stack web developer, someone that is proficient in the front end and also in the back end. Then we also have the mobile development. For all the applications that you see in your mobile phones, they are mostly done by mobile engineers. They focus on building apps for iOS and Android. Also, data science and AI. So what they do is analyzing data and building intelligence systems. They are called data scientists or machine learning engineer. We have cybersecurity, which focuses on protecting systems and data, and they are called security analysts. And also we have the cloud computing and DevOps. Their responsibility is to provision infrastructures and like uh, computers, provision computers, set up networks and deployment and then automation. They are mostly called cloud engineer and DevOps specialists. So there are other branches, like we have the UI UX design, software testing and quality assurance personnel. So there are numerous. So it's just for you to pick up your interest and then develop that skill in that particular field. So, but in this class, we are mostly focusing on web development. And the reason why we are focusing on web development is because web development is a very quick, it has a very quick feedback on what you can actually do and what you cannot actually do. And web development gives that hands-on experience with programming languages. So that's why we are starting with web development. And then we will not go too deep into it. But what this class promises is to help you be an independent learner and then carry out projects, finish projects in time, and then be able to learn at your own pace. So that's what this class promises. So now we'll talk about the career mindset and the growth part. As a software developer, as a learner, in any skill, there are mindsets you need to have as you engage or put yourself into learning that particular skill. So the first one that you need to have is a growth mindset. Growth mindset simply means have the ability to have the mind that, okay, whatsoever challenge that happens, it's not because you cannot do it, and you always seek ways to improve on what you're doing. So having a growth mindset will prevent you from doubting yourself at all times when challenges come through. Mistakes are part of learning. As you are developing, you will run into errors. So debugging the error, finding solution to the error, it's a it's a great way of learning. So if you don't have the growth mindset, there is no way you can succeed. Debugging is not failure. Yeah, it's progress. You will always make mistakes. Take note of that. So, and the next thing is that you should not give up when it's hard. Rather, take a break, ask questions, and seek help whatever way you can. So remember that any skill takes time to master. So just understand that. So the next is consistency over intensity. It's better to do 30 minutes, 1 hour in a day than to sit down and do 50 hours one day. Do 1 hour every day than to do 60 hours, 20 hours, 14 hours, like going a very long marathon, and then after that you drop it, you don't go over it again in 2 months. No, do 1 hour every day of practice to help you to reinforce the things you learn and better able to become uh, better at what you do. So being consistent is better than trying to do everything at a time. Now, problem solving is the next. So problem solving should go first. Don't just think about, okay, let me go and do it. No, always learn to break problems down into smaller steps before coding. It's not just, remember, you don't always code. Programming is not always coding. You have to think, you have to differentiate, you have to be able to design before the actual implementation. So you should always understand and know that you have to solve problem first before coding. Another thing is collaboration. I think it's software engineering that no one is actually feeling like they have to do more than you. No, everybody looks to the other person. Asking question in software engineering is not demeaning at all. Everybody understand what it is, and then when you seek help, it's even better for the person that you are seeking help from, because it will reinforce the learning of that person. So software engineers are always happy to answer questions. So please, if you are stuck, look for someone to ask, and then you make progress. Collaboration is to learn to share what you are learning, review others' code, and share your knowledge. Then the next thing is curiosity. Always be curious to learn about how something works. Always be curious. Don't just copy and paste code. No. If you follow a tutorial, always ask yourself, what other way can this be done, so that you'll be able to learn faster. So let's talk about how to succeed in this class. The first thing is show up prepared. Yeah, you cannot start something and then without being prepared for it. Have the mindset that, okay, I'm going to learn, I'm going to add something to my knowledge today. So I have to prepare to be ready to receive whatsoever thing I'm going to receive. So how do you show preparation? Watch the videos if given anyone before each class. Bring your tools, bring your laptops, bring your bring everything you need, your notes and the rest. Then your review the notes. Yes, if you take down any notes, you need to review it. Those are things you need to do to show up prepared. Then you have to adopt a growth mindset. Adopt the growth mindset. For you to succeed, you need to adopt a growth mindset. Consistency, curiosity, resilience, not giving up even when it's hard. If you don't understand something, doesn't mean you cannot know it. So please adopt the right mindset if you want to succeed in this class. Practice, practice, practice. We cannot talk anything less about it. In fact, it's the most important thing about learning. If you don't practice, there's no how you will be good at anything. So you need to practice. Do the exercises after each video. Build mini project. Challenge yourself to use online. Challenge yourself and then use online platforms, which is very important. So these are the things that you need to succeed. And we also have engage and collaborate. So engage and collaborate, we've talked about it before. Software engineering is not a personal thing. You need to speak to communities. You need to be out there, ask questions. Do not do not think that you'll be laughed at if you ask a question that maybe it's simple for others. No, others will be willing to learn, to give answers to you, and in the process, they are learning also. Stay motivated. You need to stay motivated at all times. The way you started, I know it will not be the same as you continue to experience errors and failing, but then always think about why you decided to start this path. Reflection and feedback. Always ask for feedback. Whenever you do something, ask your colleagues, ask your instructor, ask questions. Always receive feedback. Always try to get feedback. And then when you get the feedback, always try your best to ensure that you work according to the feedback. I know that with these steps, showing up prepared, adopting the right mindset, practicing, engaging, and collaborating, staying motivated, reflection, and feedback, you're going to be able to succeed as a software developer. So we are finally in the end of this session. Um, we've learned a lot. We've talked about a lot of things and the theoretical part. So subsequently, you're going to be seeing hands-on projects, practical experiences, and I'll be sharing insights on how you can actually become better at what you do. Thank you very much for your time.